That is the homework. Alright, well, let me define what a derivative is. A derivative is rate of change. A derivative, okay, D-E-R-I-V-A-T-I-V-E. The derivative is a rate of change at a given instant. Okay, so let's take an example. We remember rate of change with the slope formula, which we could write this as y2 minus y1 all that over x2 minus x1. That's change. Change in y over change in x. When you use delta y for change in y over change in x means delta x. That is the slope. We can also write this same formula is, let's say, we call this x sub 2 minus x sub 1, and that can be written as f of x sub 2 minus f of x sub 1. Okay, it's the same thing. Instead of writing in terms of y, we can call that f of x sub 1 and f of x sub 2. So it's the same formula. Okay, that's the rate of change. Okay, now what happens when this change in the bottom goes to 0? So that's like limit as delta x goes to 0 of delta y over delta x. Okay, we call that one the derivative, and we have a symbol for that, y prime or f prime of x. So it's like a little dash. It's not a 1 there, so it's like a little dash. Okay, apostrophe. Okay, so that is known as a derivative when the limit goes to 0. Of course, we can write this formula right here, and it shows up on the AP test, but we'll be able to recognize that. Limit as not delta x in this situation. Limit as x sub 1 goes to x sub 2. That means these two are getting close together. Okay, then f of x sub 2 minus f of x sub 1 all that over x sub 2 minus x sub 1 is also another name for the derivative, or f prime of x. Okay, so these are known as instantaneous rate of change, and this is known as the average rate of change. Okay, this is average rate of change right there. But here, as soon as you use the limit, okay, we're talking about instantaneous rate of change. I personally don't like this particular format, so I'm going to rewrite this using a delta x. Okay, so I need to graph this for you, so let me graph it. Okay, let's say we have some curve right like that, and we want to find the slope of this line right here, and this is my x sub 1 and this is my x sub 2. Okay, so this will be my f of x sub 1, and this y value will be my f of x sub 2. So if I want to find the slope of this line right here, okay, if I want to find the slope, I'm just going to use my slope formula, and that is f of x sub 2 minus f of x sub 1 all that over x sub 2 minus x sub 1. That's rate of change. Okay, that's the slope. Now if I bring these 2 points closer and closer together, okay, so closer and closer together, and I draw another line, and then if I bring them infinitely closer together, I draw another line. Eventually they're so close I end up getting what's known as a tangent line. Okay, and that is how we find the slope of the curve at any given point. So it's hard to find, it's easy to find the slope of a line. We can all do that. But what happens if you have a curve? What's the slope of this curve? Well, the slope of the curve is changing at all times. So it's positive here, and then it becomes negative there, so it becomes a 0 up here. But the slope of this line is the same at all times. Steepness is the same at all times. So to find the slope of a curve at a given point, let's say at this point, some point, we'll call that x, what we're going to do is we're going to bring these 2 points closer together, okay, and then we're going to start finding an equation of a line that goes through that one point, and that is known as a tangent line. And the slope of this line right here, the slope of that line is going to be the same as the slope of the curve at that point, because they're going to share that point. Okay, so that is known as a derivative when you're approximating a slope of a curve using a line. Okay, so let's come up with a different formula, which is much, from my perspective, is easier to work with. We'll call this x sub 1, and obviously that is the f of x sub 1. And then let's say we take some point here, okay, and this change, okay, is known as, we'll call that delta x. So this is my x sub 2. So the change from here to here is delta x. Well, x sub 2 is really nothing more than x sub 1 plus delta x. Okay, so instead of calling this f of x sub 2, we're going to now call this value f of x sub 1 plus delta x. So since we don't have x sub 1, x sub 2, we might as well just do away with 1 underneath that, so it won't be confusing. Okay, and we'll just call that x plus delta x. Okay. Alright, so how do you find the slope of that line? Well, the slope of that line can be found by going the slope of this line going through these 2 points, that is. Okay, if you want to find the slope of that line, I can't draw a straight line. Okay, then you're going to go f of x plus delta x minus f of x, all that over change in x, which is delta x. So instead of writing x2 minus x1, we can write delta x. Well, sometimes this can also be written, instead of writing delta x, we can call that h. So this can be also written as f of x plus h, which is change in x, minus f of x, all that over h. And this is the slope of this line right here. But we want to find, we want this h, or delta x, go to 0. So limit as delta x goes to 0, f of x plus delta x minus f of x, all that over delta x. This is known as the derivative, or f prime of x. Okay, and you can write the same thing using h, so limit as h goes to 0, f of x plus h minus f of x, all that over h, and this is also known as the derivative. Okay, what does the derivative do? That says find the slope of a curve at one particular point, so that means h is going to 0, or delta x, this is the same thing as h. So delta x going to 0, that means these points are getting closer and closer together, and if they get so close, if you were to draw a tangent line going through those 2 points right there, then you can find the slope of the curve at that point. Okay, so we call this the derivative, and sometimes it's written as a y prime, or f prime of x, and sometimes it's written as also as a dy dx, and that is known as a derivative of the function y with respect to x. Okay, and that is the same thing as f prime of x, or y prime, P-R-I-M-E. Okay, y prime. Okay, so when does a derivative does not exist? When is it that we cannot find the slope of a curve? Well, that is given to us on page 183. So now we know the definition of derivative. So on page 183, it tells you that if you have a corner, you can't find the slope. For example, let's take a curve that's like a V. Well, there I cannot find the slope right there. So f prime of x does not exist. The reason for that is the slope here is positive and slope here is negative. That means that as the limit, okay, when you have a limit and coming from the left side, this limit goes to a positive number, and since it's going down, this is going to go to a negative number. So you can't have, okay, you can't find a derivative with the limit going to two different places. That's just like saying limit as, let's say, h goes to 0 of f of x plus h minus f of x, all that over h. And this thing can't go to two different places. That can't go to like a positive number like 2, can't go to a negative number like 2, because limit does not exist, because it goes to two different values. So it has to go to same value. So whenever you have a corner, the slope will be different. So the slope does not exist, or the derivative does not exist. Okay, so that's one. The second one they talk about is when you have vertical tangent line. Okay, so when you get a vertical tangent line, so when you have a curve that just like goes straight up, okay, and right there, when the curve goes straight up, you cannot find the slope. Slope is undefined. So that means the derivative does not exist. F prime, okay, d and e. Okay, so when the curve goes straight up and down, or have a corner, the derivative does not exist. And then the third place where derivative does not exist is, let's say you have a curve like this, okay, where there's a break. Well, how can you find the slope right there? You cannot. So how about if you have a curve like that with a hole? Well, how do you find the slope of a curve right there when the point does not exist? So when it's discontinuous, the slope does not exist, or there is no derivative you can find. So three places, okay, they tell you one is a corner, okay, f prime does not exist when there is a corner like that, okay, or when you have a vertical, you know, a vertical line, the curve goes straight up and down, okay, then the slope does not exist there. And then finally, when you have a hole, then the slope does not exist right there. Okay, those are the three places. Or when you have a jump also. Let's say the curve's like that, then the slope does not exist there. Alright, so let's go ahead and find the derivative, okay, using the long method. So, and then tomorrow we'll show you shortcut. But right now, this is number 10. F of x is equal to x to the fourth. Okay, and then they want me to find the slope of a curve at x is equal to negative 2. They say a, but, okay, at x is equal to negative 2. First, we're going to find the slope, okay, this curve at any given point. So, to do that, we're going to find the derivative, and I'm going to use limit as, let's use h goes to 0, f of x plus h minus f of x, all that over h. Okay, you have to state that. Okay, and then when we plug everything into this function right here, we did that in pre-calculus, I will have a limit as h goes to 0, okay, and I have to find that. That means I'm going to plug in x plus h in place of the function, okay, into the function, I'm sorry, and then I have f of x, which is x to the fourth, all that over, okay, h. Now we have to do some algebra, which is going to kill you guys. Okay, I have to expand this binomial. We know that by binomial theorem in Pascal's triangle. Okay, x to the fourth plus 4 x to the third h. Okay, plus, okay, then what will I get? I'm going to get x to the second, h to the second, and then what's my coefficient? My coefficient is 4 factorial over 2 factorial over 2 factorial, which is, okay, 4 times 3 times 2 factorial, all that over 2 times 1 times 2 factorial. They cancel out, and the 2 will reduce this into a 2, and with 6. There it is. But you can do that also using Pascal's triangle. Then everything repeats again, and we'll have a 4x h to the third plus h to the fourth. Okay, this is done. So now I have a minus x to the fourth, and all that's going to be over h. Okay, so I did some algebra. Okay, expanded using Pascal's triangle binomial theorem. Okay, now we're going to keep on doing some algebra. If you notice that and that cancel out, and if you notice every single term, this term, this term, this term, and this term have h in them, I can factor out an h, and I'm going to show you this step, okay, so you won't be confused. So I have h, I have a 4x to the third, okay, plus 6x squared h plus 4x h squared plus h to the third, all that over h. Okay, now I can reduce the h's. Okay, so h is gone. Now I'm going to take a derivative. That means my h is going to 0. That means this is when I plug in 0 for h, that's going to go to 0. This is going to go to 0. This is going to go to 0. And this whole thing is going to go to 4x to the third. This is the slope of this curve at any given point. But what we want to know is, what is the slope of the curve at that particular point? To do that, we're just going to find f prime of negative 2, which is 4 times negative 2 to the third, which is going to give me 4 times negative 8, which is a negative 32. Okay, so this is the slope of the curve at any given point. This is the slope of this particular curve at x is equal to negative 2. That's problem number 10. Okay, so let's go to problem number 16. This is problem number 16. I have y is equal to 1 over x plus 1. In this one, they just want you to find the slope, not any particular point, but at any given point. So to find the slope of this, we're going to find f prime of x. This time I'm going to use delta x, same thing, limit as delta x goes to 0. You got to get used to both of them because you don't know what shows up on the AP test. Sometimes it will write like this, sometimes they will use an h. So some books like delta x, some books like h. Okay, so delta x. That's the definition of a slope. Got to memorize that. Okay, all we're going to do is we're going to plug everything in. We're going to find f of x plus delta x. So that's going to be 1 over x plus delta x plus 1 minus f of x, which is 1 over x plus 1. All that's going to be over delta x. And I already made a mistake. I need to write my limit, otherwise I'm going to take points off. Limit as delta x goes to 0. Okay, now we have to clean it up, do some algebra. Okay, limit as delta x goes to 0. I'm going to use the ancient Indian secret, multiply here, multiply there to subtract these two problems. So when I multiply from here to here, I'm going to get x plus 1. And when I multiply this, I'm multiplying everything by negative 1. So it would be negative x, negative delta x minus 1. And then when I multiply the bottoms together here and here, okay, and I'm going to leave it in factored form, x plus delta x plus 1 times x plus 1, and all that's going to be over delta x. Okay, let's clean up the top a little bit. If you notice, the x's are going to cancel out. Negative 1 and positive 1 are going to cancel out. What's left is a delta x, or negative delta x. So I have a limit as delta x goes to 0. Okay, negative delta x, all that over. I have a x plus delta x plus 1 times x plus 1. And where will this end up when I divide this whole fraction by delta x? It will end up on the bottom. I get a delta x. Okay, that's just simple algebra. Delta x is now reduced off. Okay, I have a limit that delta x goes to 0. I have negative 1 over x plus delta x plus 1 times x plus 1. Now I can substitute in 0, find the limit by substituting 0 right there, and that's going to give me negative 1 on the top. In the bottom, I have an x plus 1 times x plus 1, okay, which is same thing as negative 1 over x plus 1 quantity squared, and that's the slope of this curve, or we call this y prime, is equal to negative 1 over x plus 1 quantity squared. This is the slope of this curve right there at any given point. Alright, so now we know how to find the slope of a curve using the definition. Okay, let's take a look at some of the graphs here. Okay, alright, let's say we have a function, and let's say we have a curve like this. Okay, we'll call that f of x. Okay, so that's my y and that's my x. Okay, now I want you to notice that the slope here is, this slope here is positive, slope here is 0, slope here is negative, slope here is 0, and slope here is positive. Okay, I want to graph the derivative, okay, curve. So wherever there's a flat spot, that's where the slope is 0, means my derivative will cross the x-axis here and will cross the x-axis there. Okay, the slope here is positive, that means my derivative is above the x-axis. I'm just sketching the graph. Now the slope here is is 0 here, so it crosses the x-axis there, and since the slope is negative, okay, from here to here, that means my derivative curve is below the x-axis. And then since the slope is 0 here, it crosses the x-axis there, and since it's positive to the right of that, that means my derivative is going to be above x-axis. So this is my f prime of x. So this is the slope curve for my original curve. Okay, let's do a couple more here. Oops, I don't know where we got that one. Okay, let's clear that. Alright, so let's say we have a parabola to begin with. Let's say we have some parabola that looks like that. Okay, well, what's the slope here? The slope there is positive. What's the slope of this? That's there is 0, and the slope here is negative. Okay, now that's my x-axis, that's my y-axis. So if I want to graph the derivative, this is my f of x. So I want to graph f prime of x. If I want to graph the derivative, I got to find out where is 0. It's 0 there. So I'm going to go down here, and that's where my derivative crosses the x-axis. Since the slope here is positive, that means it's above x-axis, and the slope here is negative. It's going to be below x-axis, and that is the derivative, f prime of x. Okay, so basically, if you notice, last time when I had 2 humps on a curve, my derivative had 1 hump. Okay, and if my function was 1 hump, then my derivative had no humps. Okay, so I'm going to do one more. Okay, let's say I have a line. Okay, let's say I have some line that's like that, and that's my f of x. Well, what's the slope here? It's positive. See? So that means it doesn't. There's no 0 anywhere. It doesn't cross the x-axis anywhere. So my derivative curve is going to be some value, positive value. That's my y-axis, and that's my x-axis. So this is going to be my derivative curve. Okay, some positive y value. Okay, now what happens if my original curve, has a negative slope? So that, let's say that's my f of x. Okay, x-axis and y-axis. Okay, that means the slope here is negative, so that means my derivative curve is going to be below the x-axis. It's going to be horizontal. Okay, so that's my f prime of x. So eventually, if you take enough derivatives, okay, it'll end up being a horizontal line. Okay, so let's take a look at number 26. And we'll stop there. So 26. Okay, they give us a graph that looks like this. This is A, 26A. And then open circle looks like that. And they tell me this is my function. Okay, this is my f of x. And they want me to graph f prime of x. Alright, well, we know the slope is undefined here because it changed, there's a break there. So I'm going to have an open circle there. Now, the slope here is 0 because it's flat. There's no steepness. So it means my derivative is going to be 0. It's going to be there. Okay, let's put some arrows there. And then slope here is also 0. Okay, so that means my derivative is going to be there. So there it is. This is my f prime of x. Alright, let's take a look at a curve. This is 26b. Okay, in 26b, I have a curve that looks like an S curve. Alright, so we know the slope here is positive. Okay, slope here is positive. And here it's undefined. So that means my slope curve has to be, now notice the slope here is getting close to 0, it's flattening out, so the slope is getting close, it's flattening out here also when I go to the right. So when I go to the left, the slope is getting close to 0, and when I go to the right, it's so steep, my slope is going to go up. That's my f prime of x I'm drawing, and this is my f of x. Okay, now I'm looking at the slope over here. Okay, so what happens is it's a positive slope here. Okay, so that means it's coming from the top, and then it's flattening out. Slope is going to get close to 0 when I go to the right. So this is my derivative. Okay, so for the S curve, I get a derivative that looks like that. Alright, and then C. Okay, 26C. 26C, I'm going to get a curve that looks like this. And that's my y-axis, x-axis, and that's my f of x. Okay, let's graph the slope. Okay, here is getting flat, so that means my slope curve has to be close to 0, and it's also positive because it's going up. Okay, here it's undefined, so my slope curve is going to get close to 0, and it's going to shoot up. Okay, here the slope is negative. That means my slope curve has to be below the x-axis, and it's undefined here, and it's going to be a very steep negative, so it means way down here, and it flattens out. When I go to the right, it means the slope's going to get close to 0. So this curve and this curve put together is my f prime of x. F prime of x. And that's what it looks like. Okay, so let's work on that tomorrow, and we'll stop right there.